Okay, so for this talk, let me introduce myself. My name is Federico Campoli. I'm Italian. I lived in the UK for about 8 years, worked around mostly on Postgres, with some experience on MySQL. And today I will talk about hitchiker guide to Postgres. There's nothing technical on this thing. Is an introduction about the Postgres, the new features of Postgres 12, and some features they can mouth watering you, maybe. Dedicated to developers, not DBA. I am a DBA, but I understand that the logical part is an interesting thing as well. So let me introduce myself. I was born in 1972, so it means I am 47 years old. Wow, time passed by. This red cat, this ginger cat, is my little kitten. Now no longer a kitten. It's called Ozzy, from Ozzy Osbourne. And I started in the IT in 1982 because of the movie Tron. And I joined the Oracle DBA Secret Society in 2004. It was a life-changing moment for me because I discovered that the DBA career and working with databases is what exactly I love to do. And in 2006, I discovered PostgreSQL. At that time, there was a 7.4. It was a massive bet for me. And nowadays, I think the bet has been won massively because Postgres is gaining momentum and momentum. And because of that, I have a Postgres tattoo on my right shoulder. I am the second person in the world with this thing. The first is Devin Gundutz, my friend. I have this thing because of him. I was very envious when I saw him. I said, I want it. And I work as freelance DevOps and data engineer. This is my company. If you need any help with PostgreSQL, give me a shout, and yeah, I can help you. So, table of contents. There's a lot of the talk can be split in two halves. First, we will look to the history with Don't Panic, then the pan-galactic gargle blaster, the new features in Postgres 12, and the 3 Ravenous, Bugblatter, Traal. This is inspired by the Hitchhiker Guide to Galaxy. All these things are characters or quotes from the Hitchhiker Guide to the Galaxy. And so things about the data type JSON, the transaction exports, snapshot exports, and the partitioning, which is one of the improvements in Postgres 12. Is they changed things and they made very, very effective compared to the previous version, the 11. So let's start with Don't Panic. PostgreSQL starts around 1997 at Berkeley. By Professor Michael Stonebreaker. Michael Stonebreaker is a legend. Now he works for Enterprise DB, which is a company, one of the many companies in the Postgres ecosystem. And they were very lucky to bring him on board because he knows everything about the relational databases. His writings are they are still valid, and everything has been built on his writings. So the story of Postgres starts before Postgres with Ingress. I think Ingress is still around. Is a relational database. It was built by Professor Stonebreaker. Then he realized that Ingress wasn't so good, so he decided to go after Ingress and created Post-Ingress, and that's the name, Postgres. Is managed by the Postgres Global Development Group. Is a group of people, very democratic, very organized, and the idea behind the Postgres Development Group is the fact that there's no company taking over the project. So nobody can buy Postgres, differently from other open source databases. And every year, there's a new major version that adds new and new features. The last one, the latest, is the version 12. and that's been released the one day after my birthday. So it was a belated birthday present for me, and it's amazing. This is the list of the versions. If you see, it's supported on a best basis effort for at least 5 years. So at the moment we have the 9.4 end of life. It will become not supported in February 2020. So if you have a 9.4, consider upgrading as soon as possible, because every new minor version adds new fixes, security patches, and so it's not nice to stay unsupported. The minor version releases normally happens on 4 times per year. So every quarter there's a new release. And this is the schedule. If there's any very, very serious, but I don't remember it ever happened, there is a special minor release for fixing this thing. But normally those are the dates. So if you have a Postgres in production, mark the 7th of November for the next update to do. The roadmap for all the development and the schedule is at this URL. So you can find everything you need on the PostgreSQL.org website. So, pan-galactic gargle blaster. This is a pastry from my hometown, Napoli. It's called Zeppola, and it's delicious, like the pan-galactic gargle blaster. What offer Postgres? What are the Postgres features? First is ACID compliant, completely ACID compliant, differently from other databases. High scalable with MVCC allows, the MVCC is the way Postgres manages the concurrency, the concurrent access in read and write. And on the manual, on the official documentation, they say they give you a better approach than the row lock. And that's true, but there are some drawback. There are some cons in this entire thing. The vacuum is one of these necessary evil for working with the MVCC. Things will change, probably. I've been at the PostgreSConf in Canada a couple of years ago. They talked about adding the rollback segments to Postgres. Don't know when it will happen, but I think it will happen soon. Supports the table spaces, so you can distribute your data logically across physical devices. Runs of almost any Unix, so Linux, AIX, HP Unix, FreeBSD, of course, has been started on FreeBSD. And also on Windows, the port has been done by Magnus Agadner back in version 8.0. We are talking about 2004, probably 2004, 2005. That was a massive improvement. Before that, the only way to run Postgres was to use the Chigwin, which was not exactly practical and performant. And supports foreign tables. The foreign tables are something amazing, in my opinion. They're similar to the Oracle DB Link or HS or DBC. Basically, you can map local tables, spatial local tables, to external data sources. So you can attach to anything. Another Postgres server, a MySQL server, or Kafka, or even Twitter. There was a foreign data wrapper for Twitter. Now it's no longer working because Twitter changed the API. But before their change, it was possible to query the Twitter stream directly from Postgres. It was amazing. Procedural languages. You can choose whatever you want, literally. Obviously, PL/PGSQL is the most mature and best documented. We have PL Python, so we can write procedures in Python. PL Perl. There's also one procedural language for R, for statistical data. So very, very richful. And supports for NoSQL data, like HStore, key store values, and JSON. JSON is something we will see later in this presentation. The license in Postgres is different because it's a specific Postgres license. It's called the Postgres license. It's similar, very, very similar to the BSD license. And that opened the system to be forked, made it proprietary, and released under different names. For example, Enterprise DB, I mentioned before, offers the Postgres Plus version, which is closed source and offer the Oracle compatibility layer. So you can use Postgres instead of Oracle and save money, probably. It's developed in C. You can write your, using external libraries, you can build up your functions. It supports an extension system. That was a major change with the 9.2. The extension system, it makes very, very simple to add new stuff into the database, like new data types. For example, PostGIS, which is the geographical extension in Postgres, adds the geography data type and geometry data type inside Postgres with just create extension PostGIS, and you don't need to do anything else. The system will take care of creating the entire set of data. Supports partitioning. The version 12 is amazing at this level. Parallel execution, one of the few open source databases that allow the queries to be run in parallel. Logical decoding. Not exactly the best. I love the logical decoding. It's something they started with the 9.4. The one is end of life now. The problem with logical decoding, it didn't evolve too much from the 9.4. And there's still one major lack of feature inside this decoding. The DDL are not decoded. So if you alter the schema from the primary, you will break the replication on the secondary. There are tools that make this thing automatic, but it's not native inside the Postgres core. So I hope at some point it will appear, because it's something I'm really like to use, and I found very, very difficult to use at the moment. The Postgres 12, the latest release, added interesting improvements to the entire system. Normally when the new version comes in, the new major version comes in, gives some performance improvement because the code becomes more flexible, more efficient. In this case, we have partition improvement with the global foreign keys on the partitions, which was something missing on the 11, supports in one direction only, and the support for thousands of partitions. Because the architecture behind the partitioning it was still based on the inheritance, this thing created a lot of problems because of the locks imposed over the different tables and limited to hundreds of partitions, the possibility to repartition data. Postgres 12 improves this thing and raises to thousands of partitions managed. The balanced tree improve as well. The indices, they become smaller, more compact, deduplicated, very efficient on the vacuum side, so less prone to become bloated. The con in this thing is if you are migrating from a previous version, there's the risk that your index cannot be built because there's a limit over the key size of the index. Statistics. Now it's possible to create statistic defining the correlation across multiple columns. So the optimizer, it will be able to build up more efficient queries, being aware that some specific data are correlated to other data inside the same table. CTE inline. Anybody has used the with statement? It's not exactly, before the version 11, it wasn't just a cosmetic, it wasn't syntactic. It was also very, it had an impressive impact on the performance because the with required materialization and then the materialized data could be used on the lower query. With the version 12, this thing is no longer there. So by default, everything is inlined, rewritten, and the queries work efficiently. If you want the old behavior, you need to add the clause materialize to the with clause. So improvements also in this thing. So it makes life easier for developers. Prepared plan control. This is another thing I discovered on my skin. When you use prepared statements, at some point the performance can degrade. Because the optimizer can fall back on a generic execution plan because he says, oh, okay, I'm repeating always the same thing. Let's use something that doesn't need reparsing every time. Now you can control whether you use the generic or using the custom and parsed plan to keep the performance always constant within your prepared statement. Just-in-time compilation. The Achilles heel of the execution plan is you have complex queries. The time spent for calculating the execution plan and processing that thing can be massively inefficient. So the just-in-time compilation for large and complex queries rewrites the execution plan for speeding up queries. This is designed explicitly for analytics queries. Checksum control. This is a thing that has been added, if I correctly remember, in 9.3. Checksum was something amazing, but it was also very frustrating to use. You could create, you could add the checksum on the blocks, so prevent the silent block corruption, only when you initialize your data area. And normally, before the version 12, it wasn't possible to turn off and turn on this feature. Yeah, there is still around an extension made by Credative, if I correctly remember, that is called PG checksum. So you can shut down the database and disable or re-enable the checksums. Postgres 12 integrates this functionality inside itself. It's still necessary to stop the database for changing the checksum setting. Obviously, when you add your checksum, it takes a lot of time because all the checksum need to be calculated for each block. But in the future, this thing will become an online process. When? I have no idea. Maybe the version 13. Reindex currently. This is the my favorite feature. Reindex is a blocking procedure. Literally. It blocks the writes for sure, so you cannot write your data into the table, and may block your read if your query is using the reindexed index. So I've written countless times way to work around this behavior, building new indices, swapping it, and playing with SQL. Reindex concurrently allow to reindex with minimal locks. Only when the new index is validated and swapped is required an exclusive lock, which normally requires a few seconds or milliseconds, depending on the speed of your machine. Behind Postgres, we have an amazing community. I think it's one of the best communities I even work with. Normally, I don't tend to join communities, open source communities. They start well and then they become dysfunctional, let's say in this way. Postgres incredibly is improving, probably because there is a very structured way to react. We have a group of people that manage the entire direction. We have a group of committers that allow they can write into the Git of Postgres, and also the system for patching stuff. It doesn't have even the bug report system. We rely on mailing lists, and it works incredibly well. And the community works on different channels. We have the mailing list, which is the historical one, and IRC on Freenode on the channel PostgreSQL. For who likes Slack, we have a Slack on Heroku app, where several channels are created. I think there's also a Python Postgres channel. If you like to join, it will be amazing. And this is a Telegram chat. I founded this chat. It was about 12 months ago. Now we are 400 people. talking about Postgres. So if you have Telegram, please join. There's also, this is the English speaking, there's the underscore. If you go without the underscore, you will join the Russian speaking community. So Russians were arrived before me. They were the first, so they got PGSQL. I got PG underscore SQL. And if you join those communities, please be aware that there is a code of conduct. Basically, we are striving to avoid harassments or any bad behavior to continue within the community. Features of Postgres, cool PostgreSQL features. I focused on development stuff, not DBA stuff. So JSON and JSONB. We will see in the next section. Transaction snapshots export. This is another thing that we will see. And the table inheritance and partitioning. So how to partition our data. So let's start with the Ravenous Bugblatter beast of Traal, also known as the data types within Postgres. As like any database system, we have different kind of data and classic data, character, numbers, but also we have very exotic types in Postgres. Range type, we can define a range of numbers, a range of date, and use this thing as our markers for storing the data. Geometric data types, points, circles, polygons, whatever. Network address data types, XML data types. I used it for a replication system written in Python, and it worked incredibly well. I didn't know there was, how it's called, PGQ for doing the same, but it was an interesting experiment. JSON data type and HStore type. Now, let me talk about these two guys. The author of JSON and HStore is the same person, Oleg Bartonov, a genius. Initially he made this HStore data type available from the very early versions of Postgres as an extension. So external library, basically text formatted and parsed in memory. Not exactly efficient because the external library churned the CPU, and then he decided to generate this new data type. So created JSON as evolution of HStore. So it's still available, the HStore, but it's suggested to use JSON because it's more performant, it doesn't require anything to be installed, and have some interesting stuff you can use. So JSON, JavaScript object notation, you know better than me. Supported in Postgres with two flavors. We have a JSON, which is basically text parsed and validated when the data is accessed or written. So you just get the text written inside your table. JSONB is binary representation of the JSON. So it's validated at insert and update. And there's no overload caused during the read. Also, we have helper function. This is a couple of examples. For example, we can get a row and transform into JSON. The keys are automatically generated. Not exactly the best, but you can transform your data into JSON. But also, you can do the reverse. With JSON each, and in case of JSONB, we have JSONB each. We can get the JSON and transform into a record. So, and this is the way I replay the data in PG Chameleon. Read the JSON and transform everything on the fly. So, when you choose JSON, consider this. JSON is parsed and validated on the fly. So, normally, the performance can be a problem if you manipulate a lot of data. JSONB is validated, transformed at insert update. Performance are better, but the storage can be bigger than JSON because it's a binary representation. So the binary string requires more data to be stored inside the blocks. JSONB also allows a single index on the field. So you don't need to index any single keys inside your JSON. You create one index on the JSONB field, and you are done. When you change, when you add new keys, they get indexed immediately, instantaneously. The problem with this is the index is a special kind of index. It's not a B3 index. It's called general inverted index. So you can end by an index several times bigger than your original table. So you have to plan and design carefully this thing. If you don't use JSON functions, just use text. There's no point in using JSON because it's just overload for the database for parsing something that you are not really using. I will show you why this is important. So I created a fairly large JSON using JSON generator. I created 3 tables, one with the JSON, one with the JSONB, and one with the text. So this is a drop table. This is the create table JSON with the JSON element as JSON. And doing a select from this function, generate series, is very useful generating a large record set. So it just returns a set of rows. In this case, it's just 100,000 rows. So 27 seconds for storing this thing. I do the same for the text. So I load the JSON element, casting to text inside this value inside my table ttext. And I do the same on JSONB, casting on JSONB on the fly. The time for storing is quite similar. It's just a little bigger on text. But what we see at this level, the interesting thing is the sizing. It can be different. If you see the JSON table and the text table, they use basically the same space. The JSONB use more space. This is caused because the JSONB is using more data. The JSON I stored is not so big, so it triggered in some way just for JSONB the toast subroutines, which cause the data to be stored out of line or stored in a different way. If you increase this value, you can end with the same size because the database will trigger these subroutines for everything. But so depends a lot by the JSON. But in this case, it's quite impressive the difference between the 2 tables, the table JSONB and the other 2 tables. So this is the select. Just reading stupidly, select star from the table, from ttext. It takes about 18 milliseconds. Just access the data in this way. If I read the same way from JSON, the time required is slightly bigger. Because even if you don't read the data, explain it, just read the data, it doesn't return anything except the execution plan, you need to parse and validate every single row. And this is the extra CPU time added to the execution plan. JSONB is basically similar to text. Now let's add more interesting stuff. We select one element of JSON. If we select the element of JSON from the text field, we end up with 5 seconds and something from the table. So this is the way you can access your data. So in this case, because the JSON generated by JSON generator is an array containing a JSON, I need to specify the array position and then the key. And so in this thing, 5 seconds. If I read from the JSON, it's slightly lesser, about 1 second, more than 1 second faster, because the JSON doesn't need the cast required by the text. So accessing the text and transforming in JSON is CPU cost, which adds time to this operation. But the good thing is, let's do for JSON. Is incredibly fast compared to the others because there's no need for parsing the JSON in memory. The JSON is already parsed and stored on your blocks. So what to use? Whatever it fits you. And it depends a lot by your data model. as a rule of thumb, the JSONB can be a better idea for building up stuff because it's more efficient in terms of CPU. If you need to load a lot of data, JSONB can be the winner in this thing. And also, the indexing capabilities are available only on JSONB. Postgres 12 adds also the SQL JSON path language. So you can call the same query I shown before using this function and access JSON, just specifying a specific syntax for accessing this thing. And the time for accessing the data is similar to the JSON, so the JSONB access. So there's no big deal in changing this thing. It's just more clearer, probably, when you write complex queries. Now, next step is time is an illusion, lunchtime, doubly so. This is me as the fourth doctor in Napoli on the TARDIS console. Transaction snapshot. This is something amazing, I think. Has been around since the version 9.2 and has been particularly efficient and became very, very useful with the different tools implemented in the Postgres ecosystem. So what is a snapshot? A snapshot is a consistent image of the committed transactions when a query accesses the database for the first time. This information can be exported to other sessions. When this thing is exported with an identifier, another session can import this snapshot and see the same consistent image from the other session. So it's possible to use in parallel execution. You start one session, export the snapshot, import this value inside other sessions, and you read the data consistently with the original session. And this is the way pgdump, the backup tool for Postgres, does when it runs the backup in parallel. Simple example. Let's create a table. We add a primary key, ID, serial, which is auto-incremental data, content with text, t-content with text. So we add just MD5 hash into this field using the usual generate series. So we generate the counter, and from the counter we generate the MD5 and store inside this thing. Just 200 rows, just for our example. So in this transaction, in this session, we start a transaction with the specific isolation level of repeatable read. If you are curious about what the isolation level means and what are the features and the limitation of this thing, I've written a blog post. This is the URL, pgdba.org post 2019-10 transactions. Explains how this thing works and how they can affect your queries. But it's important when you export things, repeatable read has to be set, because repeatable read assumes that the snapshot is old and is never discarded, meanwhile the transaction is open. And then we run pg export snapshot, and this is our identifier. It may be different depending on the database transaction progression. So we select from our data 200 rows. In a different session, we delete all the rows. So delete from the data, and there are no more rows inside our table. Then we start again, isolation level, repeatable read, set transaction snapshot to the one we have exported in the other session, and the data, voila, they are back. So it's very, very efficient, and is very useful if you need to read data consistently across multiple sessions. Mostly harmless. Deadpool. I love him. My PC is called Deadpool. Table inheritance. The table inheritance is something that's been in Postgres since the beginning. Sometimes I like to, Postgres is referred as an object relational database system, not really a relational database system, because it implements the object-oriented programming within the database structure. And the table inheritance is something like this. You can create relationships between one parent table and child tables which share the same structure or partial, part of the same structure. You can create a child table with have all the columns of the parent plus other columns. And this was the way, back in the days, before the version 11, before the version 10, it was possible to have the partitioning in Postgres. We created a set of inherited tables, and then we managed the data across the partitions. It worked in some way. It wasn't simple, but it worked. The problem with this thing is there's no physical storage shared across the tables. The parent table is completely different from the child table. So it's not possible to create a unique constraint and force that inside the entire inheritance tree. And so it wasn't possible to create foreign keys referring the inherited tables. It was possible to run in some way, but complicated. There was no built-in mechanism for distributing the data across the child tables. Inserting into the parent table stores the data into the parent table, unless you create a trigger which redistributes the data correctly into your partitions. And there was pruning the partition, so excluding the partition when selecting. It was possible only when via the usage of the check constraint. You impose a constraint as marking the table without specific set of data, and the optimizer was able to exclude the partitions from the reading. In the Postgres jargon, this is called constraint exclusion. So partitioning in version 12 is amazing. They added the declarative partitioning, still relies on the inheritance, but improves the system. It's possible to have global foreign keys in both directions from the partitioned and the referring table. Supports the classic partitionings, range partitioning, when you define a range of data that is supposed to be inside a specific partition. List partitioning, when you specify specific values to be stored inside your partition. And hash partitioning, when you define a modulus for matching the data that should be inside your partition. So how we define this partitioning? It's very simple. We define a table and we declare it as a partition by something. In this case, it's just partition by range ID, our primary key. At this point, we cannot insert data. We will get an error because there are no partitions yet defined. So we need to define the partitions. And this is the way we define the partitions. So we create a new table, partition of, for values from 0 to 1000. The upper limit is not inclusive. From 1000 to 2000 and so on. And we can also create a partition default. So everything that doesn't fit in this thing goes inside this thing. Another cool thing about the partitioning is if you update the partitioning criteria, the row is moved across the partitions. So you don't need to care about, you don't need to worry about managing your data. Postgres will take care of it automatically. So this is just an insert. Same generate series, and this is the size of the partitions. If you notice, the main partition table is empty because the data there's no data inside, and the partitions defined for specific values have all the same size except the default partition, which takes the most of the data because I'm inserting up to 50,000, but the maximum level for the defined partition is 3,000. Well, 2,999. And there are some limitations, obviously, because the idea behind the partitioning is different. So we cannot have check or null constraint not inherited. Everything has to be completely consistent with the parent table. Partitional table does not have any data inside, so you cannot truncate just the partitioned table. You will get an error. And you cannot have partitions with more fields than the original partition table, differently from the inheritance when you can add different fields to the original set inherited. It's not possible to drop the not null constraint on partition columns if the constraint is present in the parent table. Everything, again, has to be completely consistent. So, wrap up. I tried to give you an idea of what Postgres is, how amazing it is, and I hope you will join the community, join the conversation, and contribute to the growing up this system, and use it, please. There's no charge for that. It's absolutely free. So this is the license. These are my contacts if you want to take pictures or screenshot or anything. This is my blog, my Twitter, GitHub, where I have some projects, mostly in Python. I love Python. And this is my LinkedIn. And that's all, folks. Any questions? Please be basic. I am an electrician.
So now that partitioning will be so easy and you can do it dynamically, how to figure out the right size for your partitions?
That's difficult because you need to find out how your data is supposed to be distributed. So you need to find out the rule of thumb, I think, is trying to distribute your partition evenly. So if you have, for example, partitioning by date, one partitioning may be by month or by year, depending on the amount of data. But you can also reorganize your data in some way after you decide your... there's no automatic process at the moment, as far as I know, but it can also be implemented. So I will start with a conservative approach and do not create engineer this thing.
So I guess you can query the parent table and it will query all of the partitioned tables of it. Does that mean where you're partitioning on becomes like an index? So if you are querying it, you probably need to query based on the index?
No, because the system is intelligent enough to do that for you. If you filter by partitioning key, the system will exclude the partition that do not match your where condition.
Okay,
So
right.
it's called,
so if you don't have that in your query, though, it's going to be querying all of the partitions?
Yes.
Okay.
It will access the partitions. How is not sure.
And then you can still have indexes on the parent table, and it will apply to all the partition tables. So it's managing all those separate indexes separately, because they are separate. They're just
they are different storage. So yes, when you define an index on the parent table, the indices are created on the child table as well.
Cool.
Other question? So you mentioned there are several fancy data types apart from text and all the rest. What's your experience with the blob data type? Because is it a stupid thing to put images of several megabytes into Postgres?
I won't do that. The problem with the I work with binary data. And I did for small tables. It's very useful because you back up your entire database, you're done. But if you want to use Postgres as a file system, think twice. It depends a lot but the biggest problem I see is how the data can affect the performance. Normally, if the binary data is big enough, you will get an out-of-line storage called toast to prevent the bloat across the binary data. So you can safely store it in line in your table. But it has to be big. It has to be at least 1/3 of the block, if I correctly remember. So at least 3K. But to be honest, I will use GlusterFS. and store just the reference into the database. If you need to distribute your images on different applications, I will use a distributed file system and store the references.
Other question? Okay, thanks Federico for the talk.
Thank you very much.